All right, ladies and gentlemen, we're talking about part one of 5.4. I'm going to put a little part one up here. And this is a discussion about just compound inequalities with the intersection only. So today we'll be talking about the intersection. Tomorrow you'll get a part two video which will include the union. And a big thing for us to understand what we're talking about here is one time I was in Las Vegas and there was a zip line. And I and a few friends, we chose to go on the zip line. But to get on the zip line, we had to weigh at least 50 pounds. And I have a couple fat friends, so we had to also weigh no more than, I think it was 250 pounds. And I was thinking about this when I was talking to myself, when I usually talk to myself, and thinking about the compound inequality that this specific problem entailed. And we talked about this a little bit last week, where if you had a graph of things like this, at least 50 pounds and no more than 250. So at least 50 pounds means you could weigh 50 pounds, right? So that's going to be something that we include. This is going to be a greater than or equal to 50 pounds. So I'm going to have a closed circle at 50 pounds. And no more than 50 pounds, 250 pounds. So I can't weigh no more than 250, which means I could weigh 250 because that's not more than 250. So I have a closed circle at both those spots. And all of these weights in between would allow me to go on the zip line. And that's what an intersection is, folks. It's a variable for us. So if I were to make a compound inequality, x has to be greater than or equal to 50 pounds, but it also has to be less than or equal to 250 pounds. Now I always read this from the terms of x. So I read from here as the x, and then I also read from here. So x is greater than or equal to 50, x is less than or equal to 250. And that's the big idea that we need to make sure we understand for today, is how we create and solve these compound inequalities. So here are the notes for a compound inequality, and I see that myself is going to be a little bit in the way for us, so I'll have to move the location of where I put myself today. When graphing a compound inequality and the graphs of the two inequalities overlap, both inequalities need to be true in an intersection. The word "and" is used when stating the inequality. So I already described this for us. How would you say the following inequality? It's important that you understand again that we're going to say in terms of x, we read it from the x spot first. So x minus 3 is greater than or equal to a negative 2. And then we'll say x minus 3 is less than a 4. So we use the word "and" here. So x minus 3 is greater than or equal to a negative 2. And x minus 3 is less than a 4. So that's the intersection when we have the words "and." Pay attention to our symbols here and which way they are facing. Maybe there'll be a pattern in the future. So if we solve this problem, solve and graph the solution set for n plus 2 is greater than 7, n plus 2 is less than or equal to an 11. And our process here, folks, is we want to get the n by itself. So to get the n by itself, we have to subtract 2 from all parts of the compound inequality. So when I subtract 2 to make things balanced, I've subtracted 2 from the 11, which makes me have a 9. I've subtracted 2 from the 7, which gives me a 5. Now my signs, my inequalities, come straight down exactly the way they were because all we did was subtract a negative 2. If we were to multiply or divide by a negative, our same rules apply. The signs would flip. So n is greater than 5, and n is less than or equal to a 9. So if I am going to graph this, now I could put a bunch of other numbers in here, but to keep things simple, here's a 5, here's a 9, here's a 9, we'll try again. So we'd have a 6, a 7, and an 8 in between. But I'm going to have an open circle at 5, and I'm going to have a closed circle at 9. And this is all because of my inequalities over here. And because n is greater than 5 goes this way, n is less than or equal to 9 goes the other way, these are going to intersect. That's why this lesson is called an intersection. So that means n must be a value between 5 and 9. So it has to be greater than 5 but less than or equal to 9. All right, let's try another one. And for this example, we can go ahead and solve by setting up two different inequalities, or we can create them by using one compound equality. So if y minus 3 is greater than or equal to a negative 11, and then we have y minus 3 is less than or equal to a negative 8, we can do exactly what we did before, solving the two problems by adding 3 to both sides. And we're left with y is greater than or equal to a negative 8, and y is less than or equal to a negative 5. And then we can create those two situations. I'll move Miss Johnson's email out of the way here. She'll move the whole number line. There we go. And we can graph those situations. The smaller number will be on the left. The greater number will be on the right. And if y is greater than or equal to a negative 8, we would have a closed circle in there, and a closed circle where y is less than or equal to negative 5. And because less than goes this way and greater than goes that way, the middle is where we have our intersection. That means that y has to be greater than or equal to a negative 8, but less than or equal to a negative 5. So this would be how we could write that down in a compound inequality. Everyone okay with that? I'm glad you guys responded. That was very nice of you. Thanks. Assignment. These few problems, we will do part 2 tomorrow, which will be